The third relationship in this section is what's referred to as the angle bisector relationship. And so it might look something like this. You might be given a triangle that has an angle that's being bisected. Maybe you've got some whole sides of the triangle. Maybe you've got the opposite side of the triangle being broken into parts. One of the challenges to this relationship is this is not a similar triangle situation. Okay? Even though these two angles are equal here, notice this angle appears to be obtuse, that one appears to be acute. There's no particular reason for these triangles to be similar to each other. Okay? It is proved using similar triangles. I believe there's a proof of this in your book. A lot of times we talk about it in class, but I'm not going to show it in this video. But these are not similar triangles. You just need to know if an angle bisector shows up in a triangle, it's going to divide the triangle in a proportional way, which we're going to look at right now. First of all, I don't like breaking it up like this. You may be fine with that setup. It might just be a me thing. I like to turn the triangle basically so I can kind of see the angle bisector here kind of looking like this. And okay, so I'm kind of turning my triangle around. This side's going to be 9, this is going to be 6, this little piece here is going to be 4, that little part there is going to be x, all right? And the concept is very simple, and that is the angle bisector is going to divide the left and right hand sides of the triangle in the same proportion. So whatever your ratio is over here, that same ratio is going to show up over on the other side, okay? So you can just basically divide it down that angle bisector, and you can see your two proportions setting up, okay? So x over 4 is going to equal 9 over 6, okay? And you can solve that. I believe in this case x is going to end up equaling 6 if you solve that proportion, okay? Once you do that, you can see all kinds of other relationships. 6 over 9 is 2/3, 4 over 6 is 2/3, so you can also go side to side across that angle bisector. 9 over 6 is 1.5, 6 over 4 is 1.5. You can go side to side there. There are some variations on this that potentially could come up. For example, like a lot of these other questions, you may have to do some relabeling. For example, if they tell you that that side length is 10 and they want you to find the side here, you want to compare the parts to the left of the angle bisector and the parts to the right. They didn't give you this part here, okay? So you don't want to add a second variable in, because then you have to write a system, and that's a whole other ball of wax. This whole segment's 10, this piece is x. Subtract that part right there. You can write that as 10 minus x, and you can end up with 6 over x, basically the left-hand ratio equal to the right-hand ratio. And if you cross multiply and solve there, you should end up finding out that x is equal to 4, and that'll make this side over here equal to 6 when you substitute a 4 in for x. All right? So again, just be careful. We're kind of conditioned to look for similar triangles, and this is a case where you don't have similar triangles. You just need to look at the diagram and recognize that this is an angle bisector situation.